Hello everyone. So today we're going to solve LeetCode problem number 1009, complement of base 10 integer. So in this problem, what we have to do is like we will be given an integer and we have to flip all the zeros to 1 and 1 to 0, right? And whatever we get from after flipping the bits, right? That is our answer. So here there is one example is given. So 5, right? So for 5, so you can say that the representation is this, right? After flipping the bits, the complement is 0, 1, 0. So that is 2, right? So let's look into some other examples. So here, I think we have already discussed this example. So for 7, so binary representation is 1, 1, 1, right? So it's complementary is if you see 0, then after that 1, 0, and this is 0, right? So it's 0, 0, 0, right? This is 0, right? And for 10, you can say the binary representation is this. If you take any complement, so this is going to be 0, this is 1, and this is going to be 0, and this is going to be 1, right? So this is the binary representative, which is 5, right? Then, uh, so how are we going to solve this problem? So if you see, we'll be given a base 10 number, right? So let's say we are given a number. First thing is like we have to convert it to binary, right? So binary, we have to convert it to base 2. We have to convert it to base 2. After the whatever base 2 representation we have, so we have bits, right? So we have bits. So we have to invert those bits and again convert to base 10, right? So let's understand how to convert a base 10 number to base 2 number, right? So what you have to do is like first thing is let's say we have given a number n, right? So for n, right, first thing is like we have to calculate the remainder of 2 here, right? What's let's say r, right? This is r0. After that, we have what we have to do is like n, we have to update n as n by 2, right? N by 2, let's say this is also n1. So after that, if you say this is a step, and you have to track this one. You have to put in a array, maybe array, and this is one. So you have to repeat this step, right? Repeat this step until n is greater than 0, right? And whatever r1, so after that, after completing every step, so you have r0, r1, r2, r3, right? Like rn, right? So for that, what you have to do is like you have to reverse this, reverse. So your binary number is something like rn minus 1 dot 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 you are to r1 r0. So let's understand with an example. So let's say we have 11, right? So in the first step what we have was like 11 reminder is 1, right? And after that 11 by 2 is equal to how much? It's 5, right? So after that what we have is 5, right? So 5 remainder of 2 is 1, right? After that, what we have is 5 by 2. 5 by 2 equal to 4. Sorry, 2, right? So now to reminder to 0, then 2 divided 2 equal to 1, right? So after that, what we have here is 1 reminder 2 equal to 1, 1, 2 equal to 0. So now we are finished. So if you see, this is first R1, right? R0. This is our R1. This is our R2. This is our R3. So if I'm putting this one, so this is, you can say 1, 1, 0, 1, right? Now after that you have to reverse it, right? So the After reversing, it's going to be 1011. So this is the binary representation of 11, right? So once you calculate the binary string, right? So after that, it's very easy. Only thing you have to do is like you have to flip the bits. Let's say we are getting 11, right? So let's say we have 11. So what is the binary string of it? So binary string is 1011, right? After that, we just have to flip it, right? So after flipping, it's going to be 0 1 0 0, right? Which is 8, and 8 is the answer for 11. So for a given number, so what is the process we are doing? So for, let's say we are given a number n, right? So how many bits it's going to have? It's going to have log of n bits, right? So first thing is like you are going to calculate uh, you are going to convert it to a binary string, right? So what are the steps we have? We have kind of like two steps. One is like first thing is like uh, get the bits in reverse order. After that, you have to revert it, right? String have to revert. You have to reverse the string, right? So for this, you can say it will take log 2n, right, to calculate the bits, right? After that, it's approximately we are going to have log 2n to revert uh, the bits, right? After that, once you have this, so you have to invert the bits, right? After that, you can say you have to convert those bits into a decimal number, right? It's again like you're going to have uh, uh, again you have to like do is to keyboard right? So if you see the time complexity here is you can say is 4 into O of log 2n, right? So can we do better? So one we can do better is, so let's say here what we have, right? So first thing is like to this is for calculating, right? This is for reversing, this is for inverting, and this is for like again converting to decimal, right? So here, what you can say here is we don't have to invert it, right? So whenever we are doing this calculation, right? Whenever we are doing this calculation, so invert here only. So we don't have to take this one. So after improvement, so after improvement, what our complexity is going to looks like 3 into O of log of 2n, right? So if we are doing the inversion here only, so what I'm saying here is, so let's say we have, let's take example here. So we have 11, right? So in 11, so first thing is like we are going to calculate bits right here. So first thing is that we have to calculate the bits. So in calculation of the bits, so we are going to this first thing is like we are going to get the remainder and divide it by 2, right? In that array, what we have to do here is actually we have to get whenever 1, right? 1 1 0 1, right? I think we have already done this calculation here. You see here 1 1 1 1 0 1, right? So instead of putting 1 1 0, whenever we getting that one is remainder, right? So we're saying that we are not getting a remainder one. Instead of that, in that step itself, we can do like 0. Again, like the 0, this 1, then it's 0, right? After whenever we are doing reverse, right? So then we automatically get like 0 1 0 0. So after that, we can do the like binary to decimal, it's going to be 8. So if you do follow this process, our time complexity is reduced to 3 into O of log 2n. So this is going to be our time complexity. So can we do better? can we do better here? So obviously we can do better. So how? So here, let's take a look, right? So what is our, uh, let's say for 11, right? What is the binary? 1011, right? 1011. And when we're doing the binary, right, what was the answer? It's 1, sorry, it's 100. So let me erase it. It's 0100, right? So, right. So what is it? So what is it? So it is, you can say, this is nothing but we are inverting it. So this is nothing but we are doing a XOR, right? So if I'm XOR with, so if I'm, let's say, if I do XOR with this, right? So what we are going to get is 1, 1, 1, 1, 1, and again 1, right? So what does it mean? So it doesn't mean, so let's say there is a n number, right? So let's say we have n. Here we are going to have bits, right? Log n bits. So what you have to do is like whatever n we are getting, right? So we have to XOR this number with 1, 1, 1. How many ones? So it's going to be log n ones. So means this number is nothing but n XOR of XOR of 2 to the power, you can say, how many bits we are going to have? Log 2n minus 1. This is the number. And whenever you're doing this number, right, so you're going to get the answer. So let's take the example 11 again. So in 11, how many bits we have in 11, right? So represent is 1011. So how many bits we have? 4. So what is the number in 4 bits? So it's 2 to the power 4, 2 to the power 4 minus 1, right? Sorry, minus 1. So it's going to be 15. For 15, what is it? 1, 1, 1, 1, right? So if I do XOR with this 1, 1, 1, 1, 1, 1, right? So XOR is nothing but this 1, 0. So this is 8. So this is the answer. So what we can do here is the first thing is that we are going to count the bits. This is going to take log of 2n. After that, we have to calculate. So after that, we just do the XOR. So that is again like going to take log of 2n. So time complexity here is 2 of O of log of 2n. This is the Java implementation of the solution. So here, what I'm doing here is, so I'm iterating through this while loop, right? So what I'm doing here is like I'm calculating the number of bits in the number n. So whatever number size bits I have, right? So I am doing like 2 to the power size minus 1, as I discussed earlier. After that, I'm just taking the XOR of it, right? And this is going to give me the answer. So if I'm submitting it, so that's all today. See you in the next video.